Yes, welcome everyone to the third of the webinar series from the SCAR Geosciences group. Uh, there are a few words which I would like to say. It may be repetitive for the earlier attendees of this
Okay.
series, but they are actually important to communicate. And I'm also going to talk a little bit about Kenny and Vikram, just a couple of words, that's all. So, we started with the idea from the SCAR Geosciences group that let us try to spread what SCAR Geosciences group and the overlapping or the disciplines which are shared with other groups are doing. The idea is to inform the larger audience. The idea is also to keep a recording of this and present it easily available on the SCAR web portal so that there is an increased participation, especially targeting at the national programs, and that in this way, and as I explained, it is very helpful for the today's seminar, especially. In this way, we have a much wider reach and much broader coordination and participation. So in that series, we already had few. This is the third one actually, and the third one is from an interdisciplinary groups. The title of the group is Rings. And as I keep on learning every time, it is one of the few cases where Rings has is not an acronym. It actually means rings only. And probably the idea started with one ring, but it has become rings. So the second thing which I wanted to talk about this particular topic or group today is that it is an impossible target. But looking at Kenny, he is trying to make it possible. It is also presenting an excellent example of what we are intending to do. That is, really looking and meeting with each other and trying to share the resources and to work out actually the ways in which things can be achieved. Things can be achieved by just participation and cooperation with each other. So I, of course, cannot let the cat out of the bag and rest. Most of the things will be talked by Kenny and his very young colleague and my young colleague also in India, Vikram Goel. So we will have we will have a go, and we by we I represent Jesus, myself, Laura DeSantis, and Matilde. So we all welcome you and we request you to join our subscribe to our geosciences mailing list through this sign, as well as you only have to register once for the webinar series. Please ask question. It is going to be around half an hour presentation, I believe. Please ask questions in between or otherwise from Kenny or from the group. You can direct your questions to us also, and we will coordinate in between. And if there is anything to improve what this effort is making, we will welcome all the suggestions. Thank you, and I hand over now to Kenny and Vikram. Thank you.
Thank you, Naresh, for a very kind word. Thank you very much. Yes, Bikram Goyal and myself would like to present the RINGS action group today to the Geoscience group. This action group is jointly supported by Geoscience and the Physical Science group, so that the group is very big. But I hope that we can show the outline of our work and the current status, and I hope we can generate your support and receive your support and help in the future. So Bikram, could you please share your slide and then start your part, and then I will join him later.
Sure, Kenny. So can you hear me and you can see my screen?
Yes.
Correct. Thank you so much. Thank you, Naresh, for this very kind introduction. I'll start with so Kenny has already given the brief introduction. Today we are going to talk about the RINGS action group, what it's all about and what we have been doing. We have, as Kenny elaborated, we have divided the talk into two sections. I will introduce you to the science and the motive behind the action group, and then Kenny will take over about the recent developments. Yeah, to start with, we look at the Antarctic. We look at the sea level rise projections for the year 2100, and so in these pie charts we see the different contributors to this future sea level rise by the end of the century. And there are two scenarios that we are looking at, and one thing is clear, that Antarctica is for sure one of the big or important contributors for both the scenarios. Whereas if so the amount of contribution that Antarctica has, of course, can vary based on the scenario. But one thing we find is constant is the amount of uncertainty or the share of uncertainty Antarctica brings to these estimates. And this is where the importance of Antarctica lies. It has the largest resource or reserves of frozen ice, and there is still a lot to be understand. And that is where the uncertainty, where the goal of decreasing this uncertainty stands in front of us. So if we have to tackle this issue and understand or try to minimize this uncertainty, we have the best place to start would be the Antarctic coast. And Antarctic coast is where the ice sheet, the inland ice sheet, finally reach the ocean, and then they starts to get afloat. And when they start to get afloat, they form these floating ice shelves, and these ice shelves buttress the incoming ice from the ice sheet, and in this way sort of help slow down or regulate the outflux of ice from the Antarctica. And this is, of course, where the mass loss of all the mass loss from Antarctica takes place, mostly in the form of iceberg
Vikram,
and but to carry on one thing. Yep.
Vikram, I think we
Yes,
lost
Matilda.
you for, right? Can you start over from, I don't know, a minute ago?
Yes, Matilda. Let me check my connection just to be sure. 1 second, so that it does not happen. Perfect. Sorry for the trouble. I'll share my screen.
No problem.
Yeah, whenever we test it, this didn't happen. And whenever we
It was
start a real
perfect.
seminar, then it starts. Yes, that's always like this.
Yes.
Yeah, maybe you can switch off the camera. Maybe this would help. I don't know.
Okay. All right. You can see my screen again.
Yes.
Perfect. So I will start from this slide again. So again, if you are looking at tackling the uncertainties brought by Antarctica, the best place to start, I think, would be the coast, where all the mass loss from the Antarctic ice sheet actually happens. through two key processes, of course, of calving and basal melting. But reality, of course, is a little bit more complex than that. And there are several other feedback loops and processes that are involved in determining how the mass loss actually takes place at the coastline. But coming to next slides, I would like to emphasize is that when we talk about mass loss from the Antarctic ice sheet, we usually measure the amount of ice getting out of the Antarctica at the grounding line. So just highlighting, yeah. So this is where the ice sheet starts to get afloat, and this is the grounding line. And when we have to calculate the outflux, the mass getting out of Antarctica, this is where we calculate it. So the grounding line is a very important feature of the ice sheet, and it is very much dependent upon how the different parameters, but it is also very much dependent upon how the bed topography is shaped underneath. So we have been trying to map, by we, I mean the scientific community working in Antarctica, for trying to map the bed underneath the Antarctic ice sheet since 1970. So it's been almost over 5 decades. And as you can see in these 4 figures, we have slowly covered quite some progress, okay, over these different decades. And this is the most recent coverage map. Looking at this map, it may seem that we are almost reaching to a complete coverage, but I would say that we have still some way to go. And especially when we look at the Antarctic coast, which is the focus of this study or this work. So let's look at the Antarctic. So in this figure, what it shows is that if you, at each point along the grounding line, where is the closest data point? By data point, I mean actual measurements. So for around 10% of the Antarctic ice sheet, there is a data point within 1 kilometer of its periphery, so of that point. So that is quite okay, but that is only 10%. For the rest, for next 40% of the Antarctic ice sheet, what we find is that the data point is around 1 to 5 kilometers away from the grounding line, which is, if you think about surfaces and geological features that have been mapped by glaciers, a lot can happen within 5 kilometers. So which is not good. And for the rest of the remaining 50% of the grounding line, we have the nearest actual measurement data point is more than 5 kilometers away. So, and if you look at the distribution of this data along the grounding line, along the ice sheet, so we have divided it into these 8 sections, and what we see, this is not a homogeneous distribution. So regions like Antarctic Peninsula and the Amundsen Bay, we have relatively better coverage, but still there is almost 50% of the regions where we have no data within 5 kilometers. And if you look at the area such as Enderby Line, there is a lot more to be covered. So if you want to, of course, get a complete overview, and if you want to really reduce the uncertainty brought by Antarctica, what we want is a complete pan-Antarctic coverage of the grounding line. So this is what we should be moving towards. Now, how do these current mass balance estimates of Antarctica go around this issue of data gaps? So some mass balance estimates, what they do is to, instead of measuring the outflux at the grounding line, they connect the flux gates along the actual data points, which may be far away from the grounding line, as we saw in our previous slide. So that is example for the technique adopted by Gardner et al. For their mass balance estimate. Whereas for different approach adopted by Renew, where they actually use interpolated ice thickness data at the grounding line itself. And if we compare them with another estimate, what we see is that the differences are not the same. So which sort of highlights that the estimates are very much dependent upon the type of ice thickness data used. So this again highlights that we really need to have better constraints over the ice thickness measurements along the grounding line. So this is again looking at the grounding line. We know where we of course want to know where the grounding line is at present, and we want to define it better. But we also would like to know how the grounding line will evolve with future. And this analysis, which involves ensemble analysis of the ISMIP model simulations, we find that the grounding line for almost all over the Antarctica is set to retreat. The amount of retreat, of course, will vary upon region to region. So for looking at an example for the Amundsen Bay, so here the colors show the probability of how much the grounding line would retreat. So darker colors show more probability and lighter colors show less probability. And the black curves actually here show the actual measurements of the bed we have. So this is reasonably well-informed bed topography information we have. And based on this ensemble analysis, what we see is that it is likely that the grounding line in this region will retreat significantly, about 50 kilometers. So this yellow curve here shows 50 kilometers inland from the current grounding line. So this seems likely, but then it is also plausible that we can go farther inland. Whereas if we look at on the other side of Antarctica, Totten Glacier, somewhere here, we see that the model estimates sort of agree. The dark blue and light blue colors are at the similar places. So the grounding line retreat seems to be rather predictable, but there is much less data over this region. So we really don't know how much to believe this estimate. So one clear message from this work is that the grounding line is for sure set to retreat. So if we want to keep track, it is also, along with the current grounding line, it's important to measure how the grounding line will retreat in the future. So it's important to make measurements further inland of the current grounding lines as well. And now, since we have already looked at inland of the current grounding line position, what about ahead of the current grounding line position? So this is a cross section again of the ice shelf. This would be the grounding line where the ice is getting afloat. And this is a typical cross section where we see that different ocean water masses with the warm deep water currents, which can actually melt the ice shelf from underneath. So the access of the warm deep water current to the ice shelf cavity basically is controlled by the bed topography as well. So it is one of the key information that the ocean modelers would really like to know, that how the bed topography is under the ice sheet. And this information is crucial to determine how with the changing ocean water masses, how the accessibility of the warm water to the ice shelf cavity will change and how it will lead to different melting. So in this quick analysis, what we tried to have a look was that different parts of different cavities under the ice shelves, how well they have been mapped. So there are regions like Emery where sparse airborne gravity data have been collected, and then there are areas where dense airborne gravity data has been collected, but there's only few of them. And then the area where dense airborne gravity data has been constrained with seismic data or actual ground measurements. So those are even fewer. So So there is definitely a lot of scope, and in terms of we need to map the cavities underneath the ice shelf. So this is where the idea of the rings comes. So one ring of just measuring the current grounding line will not be enough. As we just discussed in previous slides, we will need a landward ring which can take care of how the grounding line will retreat in the past, which is an important characteristic for forward-based modeling estimates. And as well at the same time, we also need to measure how the the bed topography underneath the ice shelves, and of course further outside will is shaped. And this is also important for ocean modeling and other purposes. So we instead of one ring, the idea is to have three rings. We can of course do this by using a suite of measurements, not just radar, but gravity, magnetics, snow radar, and laser altimetry. So if we have to look at different problems that we can approach through these measurements, there are several, of course, which will change based upon which ring we focus upon. So of course, primary ring is focused on ice flow discharge. This would be the first priority. And then there are other priorities that we can look at. Similarly, for landward ring, basal friction and surface mass balance are of higher probability. But this is just an exercise that we did as glaciologists. There are definitely more problems that can be, and scientific questions that can be answers through this data. And now I would like to hand over to Kenny.
Okay, thank you, Vikram. Yeah, I just want to carry over the introduction of rings and more emphasize on our groups and current work. So I hope Bikram's review about why we are doing rings is convincing, and then you will see the importance of this work and then time-sensitive nature of this work. So when we say rings, we can possibly mean three different things. Representing a SCAR action group rings. It was started back in 2021, and now we have 150 members. And the action group try to promote scientific concept rings, that's Bikram just mentioned, and facilitate collaboration within rings. And the SCAR, for example, with BedMap or Antarctica or a scientific research program Instant and beyond, like IBUXO. And then we also endorse research and survey project based on the scientific relevance, open data policy, and the EDI policy. Action group itself has no capacity to make such a research, but we try to coordinate them. And back in 2023, the COMNAP Council of Managers of National Antarctic Programs decided to support RINGS through their project, COMNAP RINGS Collaboration Project. And then we received a lot of support from national Antarctic programs. And so far, about 15 national Antarctic programs has designated point of contact for rings. They're helping us to have better communication and networking. And then, of course, they're try to ensure that COMNAP and the national Antarctic programs are well recognized for their contributions. And they are also helping us to deliver messages by the social media. Important thing I would like to emphasize is that the rings has a value only if individual rings endorse the project make the science advanced. So far, we have a 15 project endorsed or being in the process to be endorsed. And that these projects carry out the surveys or theoretical research, modeling work, satellite data analysis, and so on. As long as science relevance is clear, we endorse such a project. Next slide, please. Bikram, could you please go on the next slide? Yes. And then this is a GIF animation that Cayenne made for the group. Maybe if you know the rings for many years now, you probably remember that I put many logos into one slide, but then I gave it up because there are so many logos, and then it is GIF, so it's supposed to move, but maybe Bikram has narrower bandwidth. Maybe Bikram, shall I show the slide from my side? I have the exact copy you made so that it would be maybe a bit smoother. And now it's working. Maybe we just keep going like this.
It needed
Yeah?
an extra click, sorry.
Okay, all right. Okay, so you can see a lot of members, and then both in the SCAR side and Common Up side. And thanks, Cayenne, for making this one. Next slide, please. Okay, so let me explain about project endorsement, and I put a QR code there so you can see the full document about how your project can be endorsed. So we have the 4 endorsement criteria. First of all, we need a scientific relevance. And also we request all endorsed project to share geographical information of the project with appropriate details. For example, when you put a proposal, probably you do not have exact flight positions for the airborne surveys, for example, then you just give us the polygon where you focus on that. But as your project funded and proceed for the surveys, you can give us the flight plan or even the actual location of the flight. And then we share it with other project or use it to generate synergies with other project based on that geographical information. We request all RINGS endorsed project to uphold RINGS guiding principles and shared values, and also follow the SCAR's EDI statement. Now, I think this is very important, and we are never perfect about it, but we try to do as good as possible. And we also request all RINGS endorsed project to uphold the fair data policy. And then we request the data release as soon as possible, and the data embargo can be maximum 2 years, but we request all project to make it as short as possible. And we endorse the project in the proposal stage, so you can request our endorsement and our endorsement letter before you put a proposal to the funding agency, or your project is already funded or even already started. It is not too late to request the endorsement. And your project information become publicly available only when the project is endorsed. So if it is still not funded, this is your intellectual property, and we do not share your project information with the others. But I'm very sorry that then RINGS Action Group cannot allocate any budget from us. I'm always joking that they really appreciate the funding from Geoscience Group and the Physical Science Group, but the funding I receive from the SCAR each year is equivalent to about 2.5 drums of jet A1 fuel in Antarctica. So that's why we really need to rely on your effort to make the RINGS surveys. Next slide, please. Okay, so I'd like to show some showcase of some RINGS endorsed project. First one is actually the one I'm serving as the PI, and many nations are involved, as you can see here. And then last 2 seasons, we fly both in Drone Moderland and Enderbyland using the airplanes from Alfred Wegener Institute and the Polar Research Institute of China. So we use the 2 flight, and also Australia contribute to the Chinese flight with a QPQ based, but also other nations contribute to this survey through the logistics or the cash contributions. And you can see that in the land side, still there is no flight so far, but we are preparing for the major airborne campaign from the Japan's S-17 base and the Belgium Princess Elizabeth Antarctic Station to cover this area. And then, of course, the key resource for us is the fuel, and India is now helping us to bring the fuel to this region. This is the one RINGS endorsed project that we call Drone Moderland and Enderbyland RINGS project. The another one I would like to introduce is the project just completed the survey last season that we call the Sweden project, led by Rene Forsberg of Technical University Denmark, together with scientists from Switzerland and USA. This is quite an ambitious project. They started from the Union Glacier and survey the rings clockwise all around Antarctica. They skip the peninsula and major ice shelves because it doesn't fit into their time frame, but they carried out a primary ring survey in the most area, as you can see in the map. And then this project coordinate well with the drone model and end-of-land rings because DML end-of-land rings project already carried out the primary ring survey in their region so that they made the seaward ring. So this is a good example how individual rings and also project can be collaborate together. Next slide, please. Yes, and then I'd like to ask Bikram to introduce his own rings and also project because this is another excellent example to show the collaboration between airborne surveys and ground-based surveys. Bikram, please go ahead.
Yeah, thank you, Kenny. Yeah, for letting me share the project. So this project was called SENSE, Subshelf Exploration of Nevilicin Ice Shelf. And the primary objective of this project was to map the uh, ice thickness and the ocean ice shelf cavity underneath the Nevilicin ice shelf. This was a collaborative project between Emeritus Professor Dr. Ingve Kristoffersen from University of Bergen and NCPR. And the interesting thing about this project was with him, he brought a hovercraft, which we tested on the ice shelf, and it performed really well. And it served as a research platform in which the three-person team, we spent around 6 weeks. And the two types of measurements that we made were active seismic measurements using airgun and geophone setup. So in this figure, you have the hovercraft, and with that behind, you have connected this sled. Over this sled, we have mounted the airgun, and there is a series of geophones through which we were measuring the reflections. And then another setup that we have was towing a 20 megahertz radar behind the hovercraft. So yeah, so over the 6 weeks, we were actually able to do quite good survey and exceeded our own expectations. And the interesting thing about this survey was that we could coordinate with the DML EL rings survey being happening in the region. So in this map, the green dotted curves actually show the rings airborne surveys that were happening. And they were basically key measurements they were making over the ice shelf were the gravity measurements. And as you know, for gravity measurements, it is always nice to have some actual constraints to really constrain the bed elevation. So that is what we tried. So at several of their locations, we tried to make seismic observations and provide constraints to the rings surveys. And along with that, we also made significant ice shelf measurements, ice thickness measurements from radar. So I think it was quite a success. The project came up on a very short notice, and then I approached Rings Action Group for endorsement. And because of their endorsement, it really helped in securing funding because the science was already supported by the action group. And yes, of course, the coordination worked really well. So I really thanks at the action group for the support.
Thank you, Bikram. And then take it over to me again. So I would like to just briefly mention about recent and ongoing RINGS activities. One big milestone of the action group is the submission of the review paper to the Review of Geophysics early this summer. Summer means summer in the Northern Hemisphere in June. And then this is a huge paper with 80 authors and then the nearly 200 pages and 8,000 lines. So that's a huge paper. And then I checked the journal website this morning and I found that the journal is still looking for the reviewer. So if you ask to review this paper, please accept and help the prompt publication. In this paper, we summarized the literature, of course, review the literature, but also we analyzed published data like Bikram just presented, data availability and so on in this paper. And we released an 11 new data set. And this data set is, of course, available as a digital form, so you can analyze them further, or you can see the regions of your specific interest further to develop your own RINGS proposal. And then all data set are released as a contact-friendly data package, so it is very easy to use on the GIS software, free GIS software QGIS. Yes, thank you. If you already downloaded, it's already downloaded more than 200 times. So this is a preprint, so it can be changed through the review process, but I hope it is already useful to a large degree. Next slide, please. Yes, and then originally, we really wanted to have Antarctic rings like Rune Forsberg did for Sweden rings. However, it requires all resources around Antarctica positioned at the same timing in weeks. And I wouldn't say it is not possible because Rune made it very nicely. However, I would say it is very difficult to do. So the concept is really rings, but the implementation is to develop regional rings project around Antarctica. So we need multiple regional projects, and we coordinate these regional projects together so that at the end, there is no data gap between regional initiatives. And to develop such a regional initiatives, we are currently using white paper, and we wrote a white paper for NW Land 2-3 years ago, I believe. And then now this project was established, and then NW Land effort and the drone model and effort are merged together to be the one big project, DML NW Land project with 10 nations that I just presented. Next slide, please. And then the last year, during the SCAR Open Science Conference in Pucón, Chile, and the coming up annual general meeting in Buenos Aires, we started to prepare the white paper for Antarctic Peninsula. This is a really group effort, and you can see core author's name there, but the white paper itself is supported by many, many people. And then in this white paper, we summarize scientific priorities and the resources available in these regions, and we made recommendation of the actions as I listed there. The first thing we really need to do is to reassess existing data because existing data still has a value, and in many locations, we are not completely confident about the better picks from the radar data. And also it is important to coordinate resources of the individual national Antarctic programs. One national Antarctic program has airplane, another program has helicopter or icebreaker or runway, but now national Antarctic programs has all the resources needed for the surveys in this region. So coordinating the individual national effort at the international level is essentially important. And also, it is important to establish standardized survey protocols to ensure the data interpretability and maximize long-term science impact. And then, so now that we are about finishing writing up this white paper, so the next task is to form the regional consortium and foster open data sharing so that many people can work for the peninsula links. Next slide, please. Yes, I just put the two figures we included in this white paper showing the data availability and then the analysis of the NASA Operation Ice Bridge data that's become led. And then these would be appear in the white paper that should be available in 1 month or so. Next slide, please. And then as we are having the peninsular rings effort more established, we started to work with Weather Sea as well. So as you know very well, Weather Sea drains ice from all three major sectors, East Antarctica, West Antarctica, and the peninsula as well, and then accounting for about 20% of Antarctica's total ice discharge. And it is known that then Weather Sea region, Ronne-Philippine ice shelf, is potentially vulnerable for warm ocean water and marine ice sheet instability. And ice shelf bed topography, and then ice shelf and bed topography is particularly poorly mapped. And then the reason we started this Weather Sea is partly because Neil, Stu, Tom, and Olaf are very eager to develop this project, but also this region is just next to the Antarctic Peninsula, so we can develop the two regional effort in a well-coordinated way. Next slide, please. So this is still tentative, but then in this white paper for Weather Sea rings, we try to include this kind of matrix showing the scientific goal, priority missions, and required logistics. This is a tentative version, and I do not have time to discuss individual things. But then maybe many of you, particularly who are familiar with airborne geophysics, are surprised that rings has a big ambition to have 1,000 drums to carry out this survey. Many people asked me, Kenny, do you know how much it's cost? Yes, I know that. Well, that's why we really need international collaboration. I think none of Antarctic national programs is affordable to buy this number of barrels and carry out the surveys. But just as an exercise, if we simplify, divide this 1,000 drums by 10, individual national Antarctic program contribute only 100 drums. I intentionally said only. So in that way, I think international cooperation is truly necessary to carry out adequate surveys for rings for the next generation of the scientific knowledge. Next slide, please. So we are working very hard. The release of the links review paper is a big milestone, but we keep working as much as we can for the white papers. So the late this year and next year, we aim to finalize Peninsula and Weather Sea rings white papers and develop this regional initiative further. And we are exploring other regional rings opportunities to make rings truly pan-Antarctic. So if we have any ideas or interest to lead such regional rings project, please let us know and start a discussion. And then we are planning to coordinate a side event during the SCAR Open Science Conference in Oslo, August next year. And then SCAR has the lifetime of the action group only for 4 years, and our current term will end next year, 2026. But we are planning an extension of this term for another 4 years to 2030. And then the progress of the rings really depend on how ENDOS project can carry out the surveys. So it's very hard to say when we could finish this project, but my personal ambition is that we finish the most of the ring surveys by 2030, and we can develop something new on this rings achievement for the next IPY. But that is just my personal vision. Next slide, please. Many people asked us how we started and why we started like that. And I just want to emphasize that rings is not our new idea. This is a quite old idea, actually. I did a lot of literature survey to find out when rings type idea was first time mentioned in the literature. And I found this is the oldest one, published in 1973. I probably still was a diaper at the time, but the people, Antarctic people, already see the value of this kind of airborne network in the coastal regions of Antarctica, both for transportation and science. So the rings has been the high agenda for many decades, actually, but now it is only possible nowadays because of the high level of international collaboration and the urgent need, scientific need for global climate change. So I hope I make a good case, Bikram and I can make good case why rings is important. I really would like to invite all of you to contribute to the action group. Next slide, please. So please join us and support RINGS as an action group member. So the membership is individual. We showed logo animation. Maybe you already find the logo of your institution, but the membership is individual. So even if your colleague or you supervisors are already member of the RINGS action group, this doesn't mean you cannot sign up. We would like to have individual sign up. And then the membership is open to all who have professional interest. So if you're a scientist, of course, welcome. You're a program manager or science journalist, you are also very much welcome to join us. And then being a member of the action group is just to express of your support for the scientific concept. It doesn't mean you're obligated to contribute financially, paying the membership fee, for example, or need to develop the links endorsed project. You have no obligations, but it simply reflects your scientific support. And we have the mailing list for official announcement, and we give the opportunity for the members to develop the white paper together and sign on the white paper to show their support. So if you have interest in the membership or questions about the membership, please email to me with a brief self-introduction. And if you are interested in making your project endorsed, please check the endorsement procedure. I put a QR code there. And then I found some of the participants today already requested endorsement before the summer. And sorry, we had no time to catch up. And then your application is still pending, but it's simply because of our limited work capacity. So please forgive us and wait a little bit more. Next slide, please. So I'd like to finish this presentation with showing our global network. And Bikram and I are very happy to have any questions and feedback. Thank you so much for your attention. And on to the chat, I put some URL. Links, logo policy, endorsement procedure, links, shared values and guiding principles, and so on. So please use them. Thank you.
Thank you, Kenny. Matilda, we can have questions if there are some.
So not in the chat for now.
So if there is no question, Kenny, can I discuss one or two small points? One is that,
Sure.
as you mentioned, that the action group is 4 years. So you could also think of converting it into an expert group, which has a longer duration. That is another option. That is a suggestion. I mean, if you feel like. And the second thing is that the overarching aim of the RINGS project is looking at ice mass wastage. And the major parameter which has been thought of is the bed topography. I would like to say, of course, it is already very complex and is very ambitious project already, but the factors may be more than that. If you look at the slide in which you had shown the last one, especially the last one I talk about because of a personal bias, is the sediment control and the geothermal heat flux in that area. And but at the moment, uh, there is relatively limited interaction of that idea into the RINGS project. It will be good to have some projects which are actually not doing any survey, but they are contributing to that bed topography complemented by bed geology and structures that and of course related heat flow. That will be probably a good idea to make it more towards overarching idea of RINGS.
Yes, Naresh, thanks for your wonderful comment. While I address the first point, Bikram, could you go back to the slide number 14, I believe, for the second point? No, 12, I believe. Naresh, your first point was about the action group and expert group. And
Yes.
yes, Bikram, the one I would like to see the one with the airplanes and then the rings, if possible. Yes, the even when we started action group, we discussed whether we should be action group or expert group or even a part of the instant. We discussed that at the very beginning, and we decided to be an action group because what we are doing is basically coordinating and generating new project. For such purpose, we're really making actions rather than being consulted as expert. And frankly, I do not know the exact definition of the difference between the action group and the expert group, but we prefer to be action group to make actions. And then that's why we decide to be action group. And yes, the expert group has a longer lifetime for 8 years. But then I hope that then 4 years would be somehow adequate to make a decent progress over the rings. And then I slightly mentioned of IPY, and I said that we would like to finish rings before IPY. But I think the science is always like the answering to some questions is actually finishing the science. We're generating new scientific questions. So our ambition for the long term is to keep working in the coastal regions by generating rings 2 or rings 3 in the future. Of course, it's go beyond my career, hopefully, and in such a way, the coastal regions is really, really important. That's my first, somehow personal response to your first feedback. The second one, yes, Bikram, thanks for showing this slide. Yes, Naresh, I completely agree with you that geo domain is very important, not only the topography. And then this cartoon really capture our intention to study lithosphere as well. Of course, basal sliding is important for the outlet glaciers, but it's generated to the lithosphere, of course, and the geothermal heat flow. And the subglacial water also comes from the farther inland to the coastal regions and affect to the ice flow and ocean water circulations. So yes, geoscience is very, very important. And sorry, it's probably too small to see, but these airplane ideally carry the full suite of geoscience, geophysical equipment, not only ice penetrating radar, but also mag and grab instrument. So yes, sorry, we didn't really emphasize geo aspect today, although this is a geoscience webinar, but then we are keen to have more advancement in the geosciences as well.
Thank you. Thank you, Kenny. Are there any more inquiries or questions? Please let us know, or you can send it later on also directly to Kenny, or even through Geosciences mailing list also. So Matilde, you are the boss.
Nothing from the chat.
Yes. So maybe we can close if
Yes,
there are
yes.
no yes.
Yeah, well, thank you for the invitation for the rings. And then I missed some of the webinar already, but then I found it very useful. And then I will catch up with some presentations on the YouTube that I missed over the summer. Thank you so much.
Yes.
So thank you, Kenny, Vikram, especially for preparing for this and giving this talk after. Especially Kenny has come back from a long journey, not longer than mine, of course, but but a long journey, and it's so nice actually to be together again quickly. Okay, thank you so much.
Thank
We'll
you.
meet again later.
We meet
Thank you.
again on the 10th of September for the next seminar. Thanks.
Thanks.
Thank you.